returning how much time they simulated or how much time is left? I'd say how much time is left. Just keep it simple. So for now, we're just going to do move object, and we're going to change move object, which is complete hack piece of crap, to just returning it's going to return how much time is left. So delta t, in this case, the physics step is this. Okay, yeah, so we might not want to have it just return it. We want to... Do we want to do it at the top of every single one of these frickin' update types? Or we want to just tell it how much? Yeah, we're going to say like how much was simulated. And we're going to say it's equal to physics step. We're going to kind of break it down again. So simulated equals that. So we're actually going to say how much time was simulated. Like that. So we're passing like the full time t. I mean, we're not passing the full time t into these update functions. We're passing in what will be like the 0.005 or whatever. And if they have something else, they'll return something else. So it'll keep it easy. So if it's like, oh, we're able to move, all we do is return delta t down here. Otherwise, we return how much time we actually took. So this one should be super simple. Always good. More caffeine. More. Be nice. I should probably make like a little widget or something. It's like how much time I spent compiling, and I can just stare at that and see how much time I've lost. Just staring at progress bars in my life, and I can be like, how many years of my life did I just lose when I chose to be an engineer? And like, yeah, so you spent 5 years of your entire life staring at a freaking command prompt. I hope you're happy with your choices. Alright, cool. Well, we should now be doing our physics stuff, so let's just make sure actually we got the math right on that basic shit. So we should now be stepping at these 5 millisecond intervals with the remainder being also stepped. So we have 0.0145 and we are moving at 0.0049. The remaining dt is 0.0095, then 45, then 0. Okay, good. So we're now simulating We're moving Bitey like 3 times. And we've got like really crappy stuff right now, so you can see he's... You can see he's freaking out with his animation as well. Also moving a lot faster. Why is that? Why is Bitey all of a sudden moving quickly? Did we screw up our math? Let's take a look. Let me see, I think I've got time utils or something. So we got utils, we got time utils. I want to get the current frame. Let's see. Frame. Get real process frame. I wrote all these helper functions. So like I can do all the things. So that'll get the frame that we're on. We'll print that out, and that'll tell us exactly how many updates per frame and if we're actually moving. The main thing I'm interested in is why. Like, Bitey wasn't moving that quickly earlier, so obviously some of my math is messed up. I just want to make sure that, you know, not taking into account time, that is. It could be that I've got some unnormalized bullshit going on here, which is different. I just want to double check the time, because time's important. To physics. What do we got? We've got updating updating 0.005 on frame 564. So 5, 5, 5, blah. One, two, three, four. Why? Looks like we're double updating. 1, 2, 3, 4, 5, 6. Yeah, we're double updating. Why are we double updating? Oh, yeah. We're not double updating. We're idiot updating. Because I threw returns in there. I was like, I'll throw returns in there. I can get rid of those breaks. And then I took out the returns. So that's okay if you're doing physics sim. Yeah. Whoops, that's not what I wanted to do. Alright, we're back to slow Bitey. That's right. So we're gonna go from all this crap movement to actual movement here. Bitey will be able to fly. Bitey to the stars. Keep going, Bitey. You can make it. You can do it. Ah, damn it. Bitey's never gonna go into space. He's just not gonna be able to do it. Alright, so we're gonna be updating our locomotion. So what are we gonna do? Let's start off with what we actually need. Information we need to know. We need to know our direction of velocity. We need to know if we're standing on ground and not falling and slipping. We need to acquire the actual physics boxes which collide against the world. So, we need to get our physics state at the moment. So, let's set our current physics state at the beginning is everybody when they spawn is going to be none. And for now, basically we're gonna have like we're gonna have a thing here for tick movement, which basically is gonna say like if our current state is null, is none. Basically, we're gonna call discover physics state. So basically, when you spawn something in, it's going to try to figure out what the hell it should be doing. So, you know, a new Morg comes in, its brain's immediately going to go like, what the hell? I just got spawned into existence from nothing. It's going to figure out where it is. It's going to look around. And right now, whenever anything spawns in, we're just going to say, hey buddy, we got you covered. You are on the ground. You're on the ground. And we're also going to grab our physics box, and we're just gonna slam it into the ground, and we're gonna do a raycast to do that. So what we need to do is we need to acquire the actual physics boxes that this character has and collide them against the world. So it actually has our physics boxes right now. The thing that's got our physics boxes is going to be our flip book, because if we look at our character diagram, we got our actor, our flip book, and our physics is actually going to be on the flip book. So let's go grab it. So if we got an actor on this guy, it's alright if you can't type. I can't type either. That's pretty clear. I'm just jamming on the keyboard until something happens and something moves around, right? That's what we do. So the paper flipbook component has our physics components on it, and we want the physics components of a specific type. We want the physics components which have physics as their identifier. So what we're gonna do is, I think we're gonna modify the actor itself, and we're gonna make a function here that returns, you pass in a T array with a certain type, and it'll return to you all of the things which have that physics type. So we're gonna say get physics components, and you're gonna pass in a physics objects type. What am I doing? I want you to pass in an array, not get one. Excellent. Let's go ahead and write this real quick. Oh, this is our secondary tick function. No, we don't want that. Alright, so what we're going to do is we're going to say if our flipper component has this. So if this is null pointer, we're just going to return. Otherwise, we're going to, well, the first thing we do is input.clear. No, it's not clear, it's reset. Make sure if somebody's lazy and they don't reset their vector or their array to nothing, we'll do it for them. We'll be a good citizen. How about that? Actually, we won't. There are reasons for that. Maybe somebody wants to collect all the physics components and just keep the same T array and just roll through it. So, class definition. So, flipbook component. Paper flipbook component. Get physics components. Let's see, const T array of stuff. Const is this, so for paper physics component pointer, this is constant array. Does that matter? I don't think so. Maybe. For every comp and comp, the comp actually has what we want. IntelliSense working. So we got an identifier and an object code, and I think we wrote those functions yesterday that take our codes and turn them into things we actually care about. Get collision channel for physics code, get collision channel for physics type, get object type for code, that's what we want. So C type is going to be this. So if type equals C type, then input.add comp. Easy enough. That's not what we want. Object type, physics type. And can we actually access this? I think so. Not a problem. Alright, so now when we're inside of our movement object, all we have to do is do a T-array of paper physics components. And we're just going to do, I think it's mActor. And we're just going to call get physics components for type. Are you going to do it IntelliSense, or are you going to suck? Alright, there we go. And we'll just grab all the physics stuff off of this guy. So if our actor doesn't have any, so if comp.size is, or it's num actually for these, so if we have no physics stuff, we're just gonna return. It's like, you don't have a physics box, what the hell are we supposed to do with you, buddy? I mean, we could cast array straight down and just be like, well, you're there, because that's where you are. So why don't we just do that? Again, that's physics utils, ray trace direction. So let's just go ahead and be explicit, and we can come back and optimize stuff later. So position is going to be this right here. So that's going to be our position. Our direction. Let's see. Do we have a down direction? We have a gravity vector. Gravity vector is down, but why don't we just make an explicit down vector? Because maybe gravity changes. Never know. Never know. Which way is the gate, Ender? Which way is the gate? The gate is down. The gate is G down. Alright, so we got the ray trace, dir, the distance. How far down? Well, what was that? Numeric limits float? Yeah. We want to just cast to infinity. What collision channel are we casting as? That's a good question. We're going to cast as I think we got some functions to help with this. Yeah, we've got an entity group, so we're actually going to need the collision channel. So E collision channel chan is going to be this get collision channel for physics type. So basically we're going to need to get our entities type. I think that's on here. Our group, not our type. It's get entity group. And I'm being explicit here just because, I mean, I could write terser code, I'm just not going to. So that's our group. And the physics type is again this e.g. physics. So that's going to get the collision channel that we should be using in the raycast. So we're casting as the correct thing, so we'll be able to stand on the correct things. And we just need a T array of F-hit results. Hey Karakan, it's going well. Just working on all the things. Right now, we went through basically how we're going to do our movement and drew a bunch of pretty pictures about it, and then bitched about it, and then complained that physics is hard and collision is hard, and we don't want to do certain things. Basically, we went through, and the real problem was, I'll just draw this out because it's a little interesting, is we were going through, and we got it so like basically if Bitey is, you know, this is the ground here, and this is like the top of a log. Bitey's moving through this here, and he's like sliding because he's like, you know, doing Bitey things. He's got like his hand out here, he's got his horns on his head, and you know, those are his legs, and he's going that direction. What if he like stands up, right, and like he's now clipping and all that crap? Well, we basically said like what we're gonna do is, you know, we should be dealing with that in code. You can't stand, you know, you can't go into the standing thing if you can't stand. Like we'll have like, we need a function that would basically be like, all right, we'll grab the physics state for standing, and if standing can't be done, then you can't actually go into stand. But if like our code is all screwed up and doesn't actually cover the cases properly, what if this happens anyway? What the hell happens to Bitey? And basically what the physics what we came up with is the physics is actually still going to use this like smaller physics box just because. And it's going to say like, sure, okay, maybe you want to have that like physics container, but I'm not going to let you. So you're going to keep this smaller physics box. That way you can move normally, properly. Basically the problem is if you're penetrating an object, kind of two objects that are interpenetrating, nudging them out became a little bit too much of a problem to deal with. Like, which way do we go? And then running into situations where you're like, okay, you know, Bitey is like this, and like we're trying to nudge him over to the right, but there's like something over here in the way, and we can't nudge him anymore. Like, what the hell do we do? So we pretty much came up with, we're going to keep Bitey's collision rectangle small until, you know, you can actually make it larger, and that way we can deal with a lot of these problems. And objects are never going to interpenetrate, so you'll never have a case where Bitey is actually, you know, this is the floor and that's Bitey. Bitey's never going to be in the floor, and if he is in the floor, he can't move. And we've done something horribly wrong. So we basically enforced, we're going to have some constraints where you can never move Bitey into things. And also if you try to like spawn an enemy or somebody inside of a wall, basically they're going to be stuck in the wall. They can't do anything. They're lost to time and space. The hell with them. Deal with that. So that's what we're working on right now, is actually moving stuff and making the actual better physics movement. And to start with that, we need to place ourselves in the world and on the ground, which is where this discover physics state is just saying, well, you're on the ground, so let's put you on the ground. Yeah, he'll be stuck. Though we're gonna have a few like, you know, Hail Marys where we try to, if everything goes to hell and he's still stuck in the wall or something, it's not just gonna soft lock the game. We're gonna do a few things. And I do realize that by not updating the physics state to what the physics state of the animation that it wants to be, we're opening up the possibility of some really actually screwy bugs. Like you're able to defeat our code and make it so Bitey stands up when he shouldn't be able to stand up into a physics object. He's going to be using a smaller physics box than you would expect. And if you're then able to, like, you know, jump into some area you're not supposed to get into or something, we're just gonna let AGDQ do that. Have fun with it. Because at some point there, it's like, well, it's not reality. And I don't want to spend 2 million years writing physics systems for this crap. Because then nobody get to play the game because we just be like, no, we haven't gotten everything correct on everything, so you can't play. Alright, so if results.num is 0, then screw it. We're not moving this character. Actually, I should do the opposite. If results is greater than 0, we grab the last result, is what we want onto this guy. Yeah, I think my favorite is like the Yoshi's Island glitches that they've got, where you like spawn into some random first level in like the top left-hand corner of the map whenever you like go out of bounds. Which is just like, wait, what? Alright, so we've got our last hit, which is going to be that thing, and we want the hit result. Let's pull up the documentation for hit result. Hit result has got impact point, which is where we want to put this guy. So we'll set the set position to the impact point if we've got it. So we're basically just saying transform, that's set translation, set position, and then m actor set transform. So that's if we don't have any physics components that match our physics type. Yeah. Explore space and time outside of the bounds of the known universe. All you have to do is climb through a window. Otherwise, we need to get the physics components. The physics components are going to have a specific thing on them, aren't they? This is a paper physics component diage. So we've got sweep shape. Yeah, I think that's what we need to use for these things. Because I think what these guys have got on them is the shape. Let me see. We need to look up U primitive component real quick. I think there's like get shape from it. Yeah, so get collision shape. Yeah, so we need to get the collision shape that closely matches this primitive. Huh. Let's take a look at what collision shape is. It's got boxes, capsules, spheres. So line boxes, spheres, and capsules. So sweeping a shape is not going to allow us to sweep it's not going to let us sweep a convex hull. It's just going to let us sweep a shape itself. Well, let's take a look if there's anything else we can do about that. So let's figure out what the hell we actually need to sweep besides the floor. Sweep shape. That's how you spell shape, right? So sweep multi by channel. Alright, so it's going to be the U world has these sweep functions that we're using. So we've got sweep by channel that takes an F collision shape. And shapes are just these things. So I guess we can't shape. I mean, you can't sweep. Component sweep. Okay, so we can do a component sweep. Let me take a look at this. So we have the U primitive component. So let's take a look at component sweep multi on world.h. So sweep the geometry of the supplied component and determine the set of components that it hits. So params out hits the array of hits found between ray and whirl. Okay, so we need to make a new thing inside of physics utils that actually sweeps the primitive component, I believe. So let's go ahead and do that. And if you guys are wondering why I'm looking all this crap up, it's because I have no idea what the hell I'm doing. I'm figuring this out in real time with everyone else because I'm not a real game developer. I just pretend. I told Adam like I had worked on all these games, and that's just a big lie. I actually don't know anything. I don't even know English, so it's tough for me. So let's see. Why do I have 4 of these damn things? I think we just need to make all 4 of them. Sweep component S. What the hell does S stand for? Pause and shape, rotation channel, hits. Let's just pause end, shape channel. Okay, it's a quaternion for the rotation. So sweep with S, actually you don't have to supply the rotation. Okay, that makes sense. So we're not doing that, we're doing a U primitive component. Yeah. I'm not even a human being, I'm a robot and everything I know comes from Google. So this takes a U primitive component pointer, so we will do the same. And the reason I'm doing this instead of just going with that shape thing is because it may be the case that we have a convex hull collision on something, and I'd rather not just throw that in the trash can if there's no reason to. I just looked up the file that I'm currently staring at. I'm losing it. So what is it? Component sweep multi? Yeah, that's too bad. Oh, does it have a by channel? Okay, it does have a channel. Alright, I'm just going slowly insane. Oh, it's actually the exact same functioning. Excellent. Then all we have to do is this, and sweep multi by channel. No, it's not this. Component overlap. Okay, yeah, I was wondering, I'm basically having like a mini panic attack here over like, okay, why isn't component sweep multi taking a collision channel? And that's pretty freaking obvious when you look at it actually, because get collision, like it's like object type. Yeah, like the collision channel is on the freaking primitive component, so I'm just like, there's not enough information here. How can they do this? And it's because I should be component sweeping multi. And we don't have to specify the channel because it's already on there. Alright, so component sweep multi should take the hits, then the primitive component, and then the start and the end. Start, end, rotation, and param. Start, end, rotation, param. Start, end, rotation, param. Is there response parameters? Why are there no response parameters? So we don't have component query params, or collision query params. We don't have those. We have component query params. And we don't have response parameters. Why don't we have response parameters? Probably for good reason. That's looking more complete. Well, let's see if we've actually written this properly. More compiling. Gotta love compiling. Wait, G-down exists? Yeah, it's a vector, not a float. Get object type for physics component. Alright, yeah, I don't have to do anything for that. We already wrote it. PS none doesn't exist. Yeah, that's because it's spaced. It's gonna be a movement object. Should work. Excellent, so that goes ahead and compiles. So what we can do in here is we can actually start using that crap we just wrote. So we're going to sweep in a direction. So sweep component dir is what we're calling. And we're going to call it for... I guess that's also the thing that we need to watch out for is these guys actually have multiple boxes and the rest there. So what I'm gonna need to do is like make a bigger box around him. Sweep that. So we got Bitey here. We have his head. What I'm gonna want to do is, if we sweep this guy up there, we sweep this guy up there, we're gonna get a distance. Does this thing actually take the correct, does it take a position? Yeah, I need to double check this. This thing, I want to make sure that component sweep multi actually sweeps from the current position instead of the position of the parent of the component. The start location of the trace, the end location of the trace. Alright, yeah. That'll work properly for us. So what do you want to do for this? If we're going to be tracing this up, one of them can move, another one can move. Is there a case where we need to watch out, like, no, I think if we just trace and we just take the shortest collision, we should be fine. Like whichever one has the shortest distance. So we just go through and go through for every component in our components and grab the shortest distance. So float shortest distance is our maximum distance. And we're going to go through for every component. And comps. And we're going to get our results. So we're going to take a position, and our position is position. Is this our actual position? Or does this primitive component have a position all on its own? So it is part of an actor component. Alright, well, we'll have to double check that there isn't a position itself on the component. So if we're passing in the position here, that it's actually using the offsets from its parent for the proper sweep. Let's actually write that down. Things I need to test. So we need to test that the physics component sweep actually uses the proper parent offset for the position when it sweeps. Because if it doesn't, it's like if we have a box that's, you know, kind of off. Look at this is Bitey, and he's got like a box that's over here for some reason, kind of off of him. And we do a sweep, and with the sweep, hopefully would, like, if we say start here and go up to here, that it would actually do the sweep test with, you know, this box here moving up in this location over here, instead of like saying, oh well, this component has a center right here, so we're just gonna like throw it right here. We're actually gonna do some freaking sweep test right here, and yeah, that's physics, right? That works. Hopefully it doesn't do that crap on us. Hopefully it does what it's supposed to. The direction is going to be this direction here. The distance is going to be, again, the distance. The component is this. The rotation is nothing, so why don't we use the one that just has... Oh yeah, the S stands for simple. The S does not stand for sucks, it stands for simple. So if, what is this if? It's got a boolean on it, so I obviously did something smart. Component sweep multi will return. Of course, we got to go to world.h because the online doesn't actually have what we want. Let's see. Component sweep multi bool returns if there are any blocking hit entries. Alright, so good. We are guaranteed that if this actually gives us a hit, then we will actually have something in our results array. Why is paper physics component not a primitive component? It's totally a subclass of your primitive component. IntelliSense, you crazy, man. You're totally insane. So we're going to be able to grab the, it's going to be a blocking hit too. So basically we're going to set our position to the impact point if, if that. So shortest distance, we're basically going to do the, we're going to grab the distance off of this hit result. So if shortest distance is greater than last dot distance, shortest distance equals distance. Alright, and if shortest distance is less than max, then we are going to say our position is going to be our direction times our shortest distance. Simple. Otherwise, set position is going to default to a position, and that's what we're going to put. So this does a whole bunch of nothing. This basically is just going to take a character that we spawned into the world, and we're just going to plunk him on the ground. And it took us 30 lines of code to do it. But whatever. What is a program but a miserable pile of code? Why don't we just print this out? We are now on the ground and our position is well, the thing is, we can, once we get it squared away, you know, it'll be much easier. But, you know, there's a lot of crap that we just did. We just grabbed all the physics object off of all the physics off an object, sweeping it against the world, and it's got all this other bullshit going on. Whatever. So hopefully, what it'll basically be is we're just calling like try to move to this location, and we give it a location, and then just like it figures it all the hell out. So eventually, you know, in blueprints and other stuff.